This video is going to share with you the basic counting principles that anyone should know in any math class. They are the addition principle, the multiplication principle, and the pigeonhole principle. Really, the addition principle simply states that the whole is the sum of its parts. The multiplication principle says that if there are n ways to complete one task and m ways to complete another task, then to complete those two tasks simultaneously, there will be n times m ways to complete the pair of tasks. And then the pigeonhole principle really states that if you have n plus 1 pigeons that you release to return to their homes or their pigeonholes, but there are only n pigeonholes, then some hole has to contain at least 2 pigeons. Doubling up has to happen somewhere. It may have happened, they may be a very, very friendly group of pigeons, and they all n plus 1 may have gone into the same hole, but that means that that hole certainly contains 2. You can generalize the pigeonhole principle to m pigeons returning to q pigeonholes. Then a hole has to contain m divided by q rounded up, because we can only have integer numbers of pigeons. Let's see these principles in action. So here's the first question. When ordering a meal at a restaurant, you get a choice of one side dish with your entree. The side dishes include 3 pasta options, 2 vegetable options, and a fruit option. So how many choices do you have for your side dish? Think about it for a minute. Write your answer down. Pause this if you need to think longer, and then come back for your answer. Welcome back. I hope you got as your answer 7 possibilities, because the total number of choices is the sum of these separate options. And what's important here is that the options didn't overlap. I am assuming that there is no vegetable pasta, or we're going to classify tomatoes completely as a vegetable or a fruit, but not both. So there can be no overlaps between your parts, and then you just add all your parts up. That's the sum principle, the addition principle. How about now when you order your meal from the restaurant? They offer 8 main dishes and 7 side dishes, and when you order, you get 1 main dish and 1 side dish. How many choices do you have for how you can construct your meal? Pause for a minute, write an answer down, and start it up again when you're ready. Welcome back. Did you get as your answer 56 ways? Because there's 1 way to complete the task of choosing a main dish. I said that wrong. There are 8 ways to complete the task of choosing a main dish, and there are 7 ways of completing the task of choosing a side dish. So 8 times 7 is 56, and there are 56 different meals that can be created at that restaurant. The next question. How many 3-digit numbers have no repeating digits? Now, to be a 3-digit number, we're going to assume that the hundreds digit cannot be 0, because if it was 0, then it would only be 2 or 1 digit. So that's sort of the critical observation, is to start with the hundreds digit. Figure out your answer. Pause it while you figure out your answer, and then come back to check. Welcome back. Okay, so your first task is to select the hundreds digit, and we can't choose 0, but we can choose anything from 1 through 9, so there will be 9 choices for task 1. Once task 1 is completed, you can select the tens digit. I don't know exactly what the set that the tens digit is going to be selected from is. It's now going to include 0, but you're not allowed to select the number that came first. because we've asked for no repeating digits. So there will be 9 choices remaining. For task 3 is to select the ones digit, and you can pick anything except what already exists in the hundreds and the tens digit. So there are 8 possible choices. That means the total number of 3-digit integers with distinct digits, meaning they don't have repeating digits, is by the multiplication principle, 9 times 9 times 8, which is 648 integers. Okay, so that is another example of the multiplication principle. Finally, suppose you are handed S, which is a random set of 32 integers selected from between 0 and 200. What's the largest number of elements from this set that we can guarantee end with the same digit? Well, obviously, if we are working base 10, that's by assumption, I suppose. If we are working base 10, then the digits we can end with are either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is a pigeonhole principle problem. So the 32 integers that are in your set are playing the role of the pigeons, and they are assigned to their box or their pigeonhole based on their last digit. So here are the 10 boxes, 0 through 9, and if one of our numbers that is selected is 100, it would be assigned to box 0. If one of the numbers that's selected is 196, it would be assigned to box 6. And if the number was 18, it'd be assigned to the box 8. So we can compute the average number of pigeons per hole, or the average number of integers that end with the same digit. That's going to be the total number of pigeons divided by the total number of holes. The total number of pigeons is 32. We have 10 boxes for them to be assigned to. So the average number of pigeons per hole is 3.2. Now, we don't get fractional pigeons. That means that at least one of the boxes has an integer larger than 3.2 pigeons. So the conclusion will be there are at least 4 integers from the set S that end with the same digit. And that's our example of the pigeonhole principle. These are the really foundational principles, and they get more complicated from here, but it's really how you are applying these 3 principles to complete your tasks and break them down into disjoint sets. It's a start.